right. 12.1, lines that intersect circles. Lines that intersect circles. Okay? So basically, we're going to have a circle, and you're going to have lines that go like this. Some lines are going to meet like this. Then you're going to have lines that are line segments that look like this. Okay? So the line that goes all the way through, we're going to call the secant. So this is a secant. Okay? This guy here, a line segment that touches both sides of a circle, it's called a chord. Okay. And a line that meets at, how many points do you think it's going to meet here? Just one, right? It's called a tangent line. And this point here is called the tangent point. Those of you who end up taking calculus will become very familiar with this. Okay, tangent line, tangent point, chord, and a secant. Okay, and that nomenclature is discussed in the middle of page 792. Let's go ahead and take a quick gander at that, see if that makes sense to you. And if you do get to the point to get, that you do calculus with me, then you too can be a proud owner of a nice looking sweatshirt that looks like this. Actually, it's just a kind of a tradition that calculus class, not every calculus class does this, but they make their own t-shirts, whatever. Okay, so let's go ahead and do example number one. Example number one, identifying the lines and segments that intersect circles. It says identify each line or segment that intersects the circle A. So chords, do we have any chords there? We have E to F, right? Not the whole entire line, but just that segment E to F, right? So what I mean by that is that it is not this, but if it was just like this, it would be the chord, right? The line segment just itself, that little segment of the entire line. Okay. There's also another chord actually, and that's BC, right? BC would be a chord there. Okay. Tangent lines, well, that's easy. The L with a tangent point being C, correct? All right. Radii. Anybody know what a radii is? What's radii? It's the plural form of radius. Okay, radius is radii. Like Prius, prii. Not funny? Okay, too early for that? Okay, whatever. So, radii, right? AC and AB. Okay, and there's a secant. The entire line, EF, is a secant because it goes all the way through, just like this guy here went through all the way through, right? Okay. All right. Let's go to the middle of page, or top of page 793. Pairs of circles. Go ahead and read that through. Okay. Two circles are congruent if and only if they have congruent radii. Obviously, if the radii are the same, they're the same circle, right? That makes sense. Concentric circle, concentric. Con meaning same, centric meaning center, right? Concentric. So you have two circles that share the same center, concentric. Okay. Two coplanar circles that intersect at exactly one point are called tangent circles. Tangent circle would be a circle that has the same, it's supposed to be a circle, okay? Looks like an oval, but it's a circle. Okay, so this would be an external tangent circles, and then there are internal tangent circles that look like this, right? Because one's inside the other. But they do share the same tangent line here. Okay, all right. Example number 2. Find the length of each radius, identify the point of tangency, and write the equation of the tangent line. Okay. Well, okay, I'm not going to draw this. So what is the point of tangency there? What is the point of tangency? The point where the tangent lines both are meeting, right? Where would that be? What's the coordinate for there? The x coordinate is 3, right? The y coordinate is 0. 3, 0, right? 3, 0. That line, the equation for the line is going to be what? X is equal to 3, right? Which has a what kind of slope? What kind of slope do we call that? Huh? Undefined, right? Why is it undefined? Oh, because it goes, everything goes straight up down is undefined? Mm-hmm. Why?
Because it doesn't, the y-axis is 0.
If I were to calculate the slope, okay, go ahead.
Yeah, if you were to do the slope as over run, the 0 would be on the bottom.
Correct. So there would be no run, there would be rise, right? So let's go ahead and see. So if here, this point here is going to be 3, 0. This point here we'll call 3, 3. If I want to calculate the slope, how do I calculate the slope? Slope is delta y divided by delta x. Rise over run. You've also seen this the way you learned it. Is this one correct? Y2 minus y1 over x2 minus x1. Y2 minus y1 over x2 minus x1. 3 over 0, and you are not allowed to do this. You are not allowed to divide by 0. Hence, it is called undefined. Okay? Undefined slope. All right? Okay. So that's that. Blah, blah, blah. So that was kind of a trip down through memory lane for you guys. Okay. Blah, blah. We did that. We're good. Flip the page. 794. Common tangent is a line that is tangent to circles. Common tangent. Okay, there are internal and external common tangent lines. Externals are the one on the left. Internals are the one on the middle. Okay. You can see the difference there. Bottom of page 794. 794, there are two theorems, 12.1-1 and 12.1-2. 12.1-1. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Okay. If a line is perpendicular to the radius of the circle at a point on the circle, then the line is tangent to the circle. Okay, that makes sense? Are we good there when it says, so what they're trying to say here is if I had a circle and if I had a tangent line like this, and this is the center, this guy here is going to be perpendicular. Okay, so that's what they're saying. Okay, so example number 3. Summit of Mount Everest is approximately 29,000 feet above sea level. What is the distance from the summit to the horizon to the nearest mile? Okay. So we'll start right here, I guess. Let's say, so this is Mount Everest like this, right? And we're going to draw from here the point like this. Okay? So this here is going to be what? What is the Earth's radius? Did I give you that? I didn't give you that. It's 4,000 miles. So this is 4,000 miles. So from here to here is going to be what? This is going to be 4,000 miles plus the height of Mount Everest, right? Which was 29,000, not miles, feet. Okay, so that's that. And if I go ahead, so I need to change this to miles. So how many feet are there in a mile? Anybody remember this number? 5280, right? So it'd be 5280 miles, right? And what do I get? How much? 5.49. 5.49. So this is going to be 5.92. 5.49, I'm sorry. 5.49, right? So this guy is 5.4. So this guy here is 5.49. This guy here is going to be 4,000. 4,000, 5.49. This here is going to be 4,000. What was the question? What is the distance from the summit to the nearest mile? So we're trying to find this guy here to here, this distance here, x. Right? So this guy squared is equal to x squared plus 4,000 squared. Can we see that? In this triangle, because this is 4,000, this is x, and this is 4005.49. And if you solve that, you're going to get 10. Okay. So that's that. In the bottom of page 795, there's another theorem, 12.1-3. If two segments are tangent to a circle from the same external point, then the segments are congruent. Does that make sense? Can anybody tell me why this is true? Anyone tell me why this is true? Can you see that this has to be 90 degrees? Right? So let's look at triangle AOC and triangle BOC. AOC and BOC. So this triangle here and this triangle here. can you see if I call this guy, we'll call it y, I guess, I don't know, right? What is this distance here? This is called the what? What is this distance here? Still the radius, right? So can you see that AC squared plus R squared is equal to Y squared in this triangle? Y being the hypotenuse, right? So the hypotenuse squared of this squared times this squared, and plus this squared, I'm sorry. BOC, same triangle, right? BC squared plus R squared is equal to Y squared, right? So therefore, AC and BC have to be the same, right? Okay. So that's what they're saying there. The two segments, AB and AC, are congruent. Okay. All right, let's go ahead and flip the page. Let's go ahead and see if we can solve this. Example number 4, using properties of tangent. So in this one, we have, I'm not going to rewrite this because I'm lazy, basically. So we're going to call this 5y minus 28. And this guy here is going to be 3y. So this guy and this guy have to be the same, right? Right, basically. So I'm going to get 5y minus 28 is equal to 3y. Somebody solve this for me. How would I solve this? Huh? What?
You subtract 5y from 3y. And so you make it
Sure, you could if you wanted to. And if I subtracted 5y on both sides, I'm going to get, right? And then what's the next step?
And then you divide by -2.
This guy cancels out. I get only y. Here I get what?
14.
14. Y is equal to 14. And then what the question says, if they're going to find the df, they want us to find the actual line, not just y. Okay, so you have to pay attention to what the question is asking. The question actually asks for what is the length of df. So length of df is 3y, so your answer is going to be 42. Okay? And we are done with 12.1, and the homework is (1 through 22).